All right, it's time to look at fractions that are greater than 1. What are we talking about? Yep, we're talking about mixed numbers. We're talking about a whole number with a fraction part. All right. Let's look at whole numbers and how they, fractions and how they, affect the whole. In your books, on page 189, turn to page 189. Explore changing wholes. Before you decide how much a fraction represents, you need to know how big the whole is. In other words, not all 1/2s are equal. They have a different value. They're worth half of something, but that half can be a different amount. Would you prefer to have half of a large watermelon or half of the small one? Well, I like to think of, forget the watermelon. No watermelon. Let's change this to ice cream. All right. Would you like to have half of a large bowl of ice cream or half of a small bowl of ice cream? Well, of course, I'd like to have half of a large bowl because that's more ice cream. Even though both are 1/2 of something, 1/2 of something larger is more than 1/2 of something smaller. Number 2, would you prefer to sweep 1/3 of the gymnasium or 1/3 of your classroom? Well, if you want to get done faster and have less work, you want to sweep 1/3 of your classroom because your classroom is smaller. So 1/3 of your classroom is less than 1/3 of the gymnasium, even though 1/3 is the same fraction. All right. Looking at the bottom, page 189. Look at these. Only one square, and all the squares of the same size are shaded, but it has a value of different parts. So now we're looking at the same size something being represented by different fractions. Because in number 3, and let's call that the teal square, is the same size as the purple square in number 4 and the orange square in number 5, but the fractions are going to be different. Let's explore this. Look at number 3. The fraction of the shaded part of number 3 is 1/5. The fraction for the shaded part in number 4 is 1/6. The squares are the same. This teal square is the same size as this purple square, but yet the fractions are different. Okay? Pause your video, complete the fractions for 5 through 8. Go. All right, so we have 1/9, we have 1/3, we have, what is that, 3, 4, 5, 6, 7, 8, 9. We have 1/9. Another 1/9. No, that can't be 1/9. 4, 5, 6, 7, 8, 9, 10. That's 1/10. Good catch, Mr. Woody. You're so smart. 1/10. And we have 1/7. Okay? Again, each of those squares is the same size, but it's part of different size groups, so the fraction is different. Okay? And we just explained that for number 9. They're all the same size, but they're part of different size groups, so the fractions are different. The numerator, all 1, is the same, but they're all part of different size groups. One group of 5, one group of 6, one group of 9, one group of 3, one group of 10, and one group of 7. All right, move on. Here we have, don't look at your books right now. Here we have our first example of a mixed number. But let's look at it by fractions. The shaded parts are all fourths. So here we have 1/4 here, 1/4 here, 1/4 here, and 1/4 here. So we put those together. Oops, forgot 1/4. We put those together in a chain. We have 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. That is the chain of the shaded parts. Well, that equals 5/4. There are 5/4 of these circles shaded. How does this become a mixed number? Well, 4 of those make up one whole circle, which 4 of these make up 4/4. Okay, we can change that into 1. And then what do we have left? We have the 1/4 part. The 1/4. 1 and 1/4. See that? So it becomes a mixed number. we take the 4/4 and then what's left? Let's look at the example of this. Here I have circles cut in halves and shaded. If I make the chain for this, each one, we have 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2 equals. How many halves is that? 1, 2, 3, 4, 5, 6, 7. 7 halves. Okay, so this part here represents 1 whole. This represents 1 whole. This represents 1 whole. And that's a half by itself. So I have 1 plus 1 plus 1 plus 1/2. Then if I can see further, the 1 plus 1 plus 1 is equal to 3 plus the 1/2. And that equals 3 and 1/2. When I look at it, I've got 1, 2, 3, and 1/2. Okay, so mixed numbers are the wholes put together, and then the fraction part that's left over that doesn't make it to the next whole. The improper fractions of 7 halves that I'm circling here in black, and how that gets down to, and how we can directly change that into a mixed number and back and forth. All right. Now we're going to look at how we change and go back and forth between the... So, changing a mixed number into an improper fraction. So if I have the mixed number, let's just start easy, 1 and 1/2. Okay, the denominator is how many parts we have the whole, and the whole number is how many of those parts we have. So we take it's a circle of happiness, we learned this last year, the 2 times 1, and we multiply that, 2 times 1, and then we add the numerator, and we put that number as our new numerator. 2 times 1 is 2, plus 1 more is 3, and we put that over the same denominator, 3 halves. Okay, let's try another one. Let's go up to 4 and 2/3. Okay, I'm going to take the 3 times 4. 3 times 4 is 12, and 12 plus 2 is 14. And then I put that over the same denominator, 3. So going from an a mixed number to an improper fraction, I take the denominator, which is how many parts the whole is broken up into, multiply that by the whole number, which is how many of those complete wholes we have, and then I add the numerator. Let's try one more. Let's try 3 and 2/5. Okay, we know the denominator is going to stay the same. Then I take 5 times 3 is 15, and then plus 2. 15 plus 2 is 17. 17/5. So circle happiness. Multiply and then add for your new numerator. Denominator stays the same. Let's have you try one of those. Let's have you try 3 and 1/3. Pause your video and do 3 and 1/3 now. Okay, hopefully you came up with 3 times 3 is 9, plus 1 is 10 thirds. All right, what do we do to reverse this now? To change from an improper fraction to a mixed number. Let's say we have 9/4. Okay, 4 is how many pieces we need to make one whole. So for every 4 pieces of the 9, we're going to have one whole. So if we go 1, 2, 3, 4, that's one whole. 5, 6, 7, 8, that's one whole. And then 9. Okay, we have 2 wholes and 1. How many times is 4 going to 9? 4 fits into 9 2 times. We're actually going to divide. So we say 4 fits into 9 2 times, that's our whole number. 2 times 4 is 8. What's left over? 1. And that goes back over the denominator again. Okay, let's try another one. 5 halves. Okay, how many times does 2 fit into 5? 2, 4, that's 2 times. Okay, what's left over from 4 to 5 is 1. And it's back over the same denominator. Okay, let's have you try one. Let's have you try, let's go 7/3. Pause your video and try 7/3 now. Okay, so how many times does 3 fit into 7? We say 1, 2, 3, 4, 5, 6, 7. Okay, we have fits in there 2 times with 1 left over, 2 and 1/3. That's how we change improper fractions to mixed numbers. We can go back and forth. Okay, let's move on. All right, here's some to try. I want you to pause your video and try changing 1 and 2, 3, and 4 from mixed numbers to improper fractions or improper fractions to mixed numbers. Pause your video and start these now. All right, let's work these and see how we did. Okay, again, when we gather these, we count. We've got 1, 2, 3, 4, and 5. I've got 2 and 1/2. Number 2, circle of happiness. 3 times 3 is 9. 9 plus 2 is 11 over 3, 11/3. Okay, back to improper fraction to mixed number. And how many times does 4 fit in 9? We've got 1, 2, 3, 4, 5, 6, 7, 8, groups of 4, and 9. That makes 2 and 1/4. Okay, and now circle of happiness, changing a mixed number into an improper fraction. And remember, improper fraction, we call an improper fraction when the numerator is larger than the denominator. 5 times 2 is 10. 10 plus 3 is 13. Denominator is 5. 13/5. All right, this is what you're going to be doing for your homework. And your homework assignment is going to be homework and remembering for 5 dash, make sure I got the right lesson here. Yes, 5-6. Okay, again, we're doing things that we did do last year, but we're taking it, taking the review so we can add to it and build on it. Homework and remembering 5-6. Get started. Get her done.